lesson today looks at adding and subtracting radical expressions. Important thing to keep in mind when you're adding and subtracting radical expressions is just the idea that the radicand is the number on the inside of the radical symbol, and your constant, which is sometimes an integer, is the number on the outside. When you add and subtract radical expressions, the radicand and the index must match exactly. So the number on the inside has to match exactly. So down here, when we have the square root of 5 and the square root of 5, those do match, so we can simply just add these up. 3 plus 7 would give us 10 times the square root of 5. That becomes our answer. Okay? If the radicands do not match, simplify your radicals first, and what happens is every so often that'll get it so that your radicands will match. From there, you're just going to add and subtract the integer, or the constant, in front of the radical to simplify. For number 2, we're just going to take 6 minus the 4 because the radical 2 and radical 2 match. So 6 minus 4 is 2. So I have 2 radical 2 is my final answer. Over here, the square root of 7 and the square root of 7 match. So I just take 18 minus 26, and I get negative 8 times the square root of 7. Again, we just keep the radical the same, the radicand, and all we do is we work with the integers or the constants in front. Here we have 1 times the square root of 5 and 1 times the square root of 5, so we should have a total of 2 times the square root of 5. Over here we have the square root of 3. There's just one of those, so we say 4 plus 1 is 5 times the square root of 3. Over here we have 13, so just 1 times the square root of 13, minus 7 times the square root of 13. 1 minus 7 just gives us negative 6 times the square root of 13. Continuing this, we'll notice that at number 7, our radicands don't match. We have the square root of 5, and we have the square root of 50. So our advice was to simplify this as much as we can. That'd be this 25 times 2. This breaks down into 5 and 5. What happens is we have a pair of 5s, which would give me 5, and the 2 is left over, like so. So my answer is now square root of 5 minus 5 square root of 2. Do your radicands match? They don't, so I can't add or subtract anymore. This is my final answer. Kind of a weird final answer, but that is our final answer. Over here, 27, we'll break this down. This will be 9 and 3. This breaks down into 3 and 3. That means I have a pair of 3s and a 3 left over, so that just gives me 3 radical 3. Over here I break this down into 25 and 3. This is 5 and 5. I have a pair of 5s, so I can pull that out front. I'm left with the square root of 3. At this point I notice that I have 2 sets of square root of 3s. My radicands are the same, so I can simply add the 3 and the 5 together to get 8 square root of 3. I'll break this down. 24 could be 6 and 4. 6 is 3 times 2. 4 is 2 times 2. I notice there's a pair of 2s, so I'll have the 6 times 2 with a 3 times 2 on the inside. It gives me 12 times the square root of 6. 48 I'll break down into 16 and 3. This simply breaks down into 4 times the square root of 3. So my answer just turns out to be kind of unsatisfying here. 12 times the square root of 6 plus 4 times the square root of 3. Not every single time that you break these down will you be able to add your radical expressions together. Look at number 10. We notice that there's 11s involved. This would be 4 times 11. 4 gets broken down into 2 and 2, so this becomes 2 times the square root of 11 minus. This becomes 9 times 11, which is just 3 and 3. So that's minus 3 times the square root of 11. Since the square root of 11s are the same, I'll just say 2 minus 3 is negative 1 times the square root of 11. Or probably just the best way to write this is negative square root of 11. We can break down 98. That would be 49 and 2. 49 breaks down into 7 and 7. So I have a 4 on the outside that I just bring down. I have a pair of 7s, and I have a 2 left over. So that's what this looks like. When I break down 32, that becomes 16 and 2. 16 is a perfect square. I can break that down into 4 and 4. So I would just have 4 times the 6 with a leftover 2. When I simplify this, this becomes 28 times the square root of 2 plus 24 times the square root of 2. Since my square root of 2's are the same, I can simply add these two together. 28 and 24 gives me a total of 52 square root of 2. If I look over here, I can continue the same process. This is the square root of 208. I know that that's divisible by some nice numbers. We'll say that's 104 and 2. 104 gets broken into 52 and 2. 52 becomes 26 and 2. This is 13 and 2. Okay? Again, sometimes you don't notice the nice patterns as we go along. I'll notice that there's a pair of 2's, so I'll just circle those. I can put that out front with my 15. I'll notice another pair of 2's, so I can put that out front. And what's left over is a square root of 13. Over here, 15, oh, I've already done this one. This is 26 and 2. This is 13 and 2. I'll notice that there's a pair of 2's, so when I have this, I'll say minus 2 times the square root of 13. 15 times 2 is 30, times another 2 would give me 60 times the square root of 13, minus 2 times the square root of 13. 60 minus 2 would just give me 58 times the square root of 13. If any of this is going too fast, you can always back things up. You can always slow them down. You can always hit pause at any time. Just make sure that you're able to follow along and make sure you're able to do this work. Remember 13? I can break 90 down into 9 and 10. 9 breaks down into 3 and 3. 10 is 2 and 5. I notice that there's a pair of 3's, so I can put this 3 on the outside with my original 3. And what's left over is a 2 and a 5. That would give me a total of 9 times the square root of 10 for my first block. 40 breaks down into 4 and 10. 4 is 2 and 2. 5 and 2 make up the 10. I'll bring down my original 4. I'll notice my pair of 2's. And I'll have 2 and 5 left over. This will give me 4 times 2 is 8 times the square root of 10. 9 plus 8 should give me 17 times the square root of 10. For this guy, this is going to be 4 and 3. 4 breaks down into 2 and 2. So this will give me 3 times the 2 with a square root of 3 left over, or 6 times the square root of 3. 27 breaks down into 9 and 3. This gives me 3 and 3. I have an 8 that was on the outside. It's actually negative 8 times 3 with a remaining 3 left over. When I take out my pairs, that's this one. The 3 is the one that's remaining that goes back in there. When I multiply these together, this will give me minus 24 times the square root of 3. Notice again my radicands are the same, so I'll just simply take the constants or the integers out front. 6 minus 24 is negative 18 times the square root of 3. I keep my radicand. If you break down 28, this will give you 4 and 7. 4 is just 2 and 2, so this will give me 2 times the square root of 7. 63 is 9 times 7. This will give me 3 and 3. So this will give me plus 3 times the square root of 7. Notice again my radicands are the same. So I'll just say 2 plus 3 is 5 times the square root of 7. Sometimes when you get stuck with these and you're not sure how to break things down, sometimes it works out well to kind of look, well, I have a square root of 7, so maybe this number is divisible by 7. Sometimes it's a really good hint for us. Another hint that you might use is always try to see if there's some perfect square that goes into each of these numbers. So I might notice that 6 plus 3 is 9. Any number whose digits add up to 9 or a multiple 9, it's also divisible by 9. So you might use those as some of the tips when you're working to break these down. These next two problems are kind of tough. There's constants outside the radicals, there's radicals that aren't the same. It kind of looks like a big mess, and these are as hard as these problems get. So we'll take a look at these. We'll just break down each of these and hoping that something nice will happen. We'll notice that 9 can be broken into 3 and 3. So I'll have a 2 on the outside times my pair of 3's with a 2 left over. So give me 6 times the square root of 2. 8 breaks down into 4 times 2, or 2 and 2. So I'd have the 4 on the outside times my pair of 2's with a 2 left over. That would give me an 8 times the square root of 2. I'll simply just bring down these other constants. This is 6 plus 6 square root of 2. I'll bring down my minus 13, stick that in here, and there's also an addition in here. What I have to do is, if I just have constants all by themselves, I'll just add or subtract those. So 6 minus 13 is negative 7. And then I look at these that are matching radicands, and I'll say 6 plus 8 is 14 times the square root of 2. This becomes my final answer. Generally speaking, I'll write my constants first, and then I'll write anything that has a radicand or radical symbol with it. And again, the way I get the negative 7 is I just look at just the constants that are by themselves, and then I look at any of the radical expressions, the ones that have radicals in front of them. If they do have the same radicand, again, I can make sure just to add those together. For this last one, we'll break 28 down into 4 and 7. 4 is 2 and 2. 63 breaks down into 9 and 7. This gives me 3 and 3 again. When I simplify these expressions, I'll have 5 times 2 is 10 times the square root of 7. I'll add my 9. I'll subtract from that. 4 times 3 is 12 times the square root of 7. I'll tag my 11 on the end. Again, I'll take 11 and 9 and add those together. That'll give me 20. And then I'll focus on this. It won't be a plus sign though. It'll simply be a minus sign. So 20, and then I have 10 minus 12, so it should give me negative 2 times the square root of 7. Make sure that you have really good attention to detail when you're working these problems out. This, again, is probably the hardest section that we've worked on, is adding and subtracting radical expressions.